Hey everybody, what's good? What's going on? JB here with another CyberInsight live stream. Today we're going to be doing something a little bit different. I've been starting to do a little bit of studying for the Comptia Pentest Plus certification, and in going through my study materials and looking at kind of some different options for getting some hands-on stuff, I saw that TryHackMe has a learning path for Pentest Plus, so I figured if I'm going to be going through some of the labs in there, why not live stream it, maybe go through some of that material, answer some questions. Either I'll be helping you out or you're going to be helping me out, because this is a little bit outside of my lane. As all of you know who've kind of followed along with the channel, I'm not a pen tester. I don't do red team type of stuff in my day-to-day activities. Taken some classes and messed around with Kali and stuff like that, but the stuff that I've learned before I've probably forgotten by this point. So yeah, we're just gonna jump into it and kind of go from there and see how things go. Let me hop over to my web browser for this. Perfect. If you have any questions as we're kind of going through this, you can go ahead and drop those in the comments. And yeah, we'll kind of address those as they come up. So real quick, just to give you a little bit of an idea of where we're going to get into this here, TryHackMe has a whole bunch of different modules that you can do for different types of pen testing and stuff like that. What we're looking at here is our Comptia Pentest Plus learning path. I believe that, I'm not sure all of them are free, but some of them are free. So you can just sign up with an account. You actually don't need to have a virtual machine and connect via VPN, although that is an option if you want to do that. We're just going to be using their in-browser machine on this. And the NMAP room that we're doing today is kind of their first one, and it's free. So figured why not give that a spin. So when you go to do this, you actually have a few different machines that you need to spin up. I already did that ahead of time because that takes like 5 minutes from them to spin up. So kind of just hit start machine and that does that. It also normally would do it in a split view, but I thought that that might kind of look crappy when it comes to folks looking at this. So kind of put that into a different browser here so we can kind of hop back and forth. And as we go through these different tasks, some of it is a bit of text, kind of teaching you a little bit of background information. I'll try to summarize that as we go through. I haven't gone through and done this stuff, so this is going to be pretty much the first time that I've gone through all of this, and hopefully it's not too confusing. So we'll see what's going on. Hey, Davin, what's good, man? Appreciate you dropping in. So yeah, we already deployed the attached VM. We can go ahead and mark that as completed. This section here, I mean, it looks like they're just kind of giving you a little bit of an understanding about how different port communication happens. Talking about the 65,535 available ports. Different services are assigned to different port values. And why NMAP? Well, NMAP is going to be a tool that's going to allow us to see if devices are on the network, see what ports are opened, and we can kind of do a little bit of polling for different types of information to see what is out there and available. Although, obviously, if you have different types of access control lists on your environment, then that can limit what you can and can't see. So, let's see. First question here. What networking constructs are used to direct traffic to the right application on a server? I think that's going to be ports. Cool. And how many of these available on any network-enabled computer? I just said that was 65,535. Worth noting, even though they didn't mention that there, that also is per per protocol, so 65,535 TCP ports or 65,535 UDP ports. It's good distinction to make. And how many of these are considered well known? Well, if you have followed along with any of our Network Plus stuff that we've talked about in the past, that should be 0 through 1023, which should be 1024 total, because 0 counts. See if that's right. Cool. Now, interesting thing is we kind of go through this. Some places they actually have hints. And so let's just kind of see what the hint would have told us to do if we didn't know what that was. Search in Google, how many well-known blanks are there, substituting your answer for question 1. So we could have went and Googled that. I do have a Google page up here in the event that we do need to do that. I've got some other comments coming in. Hey, Patrick, appreciate you dropping in. And let's see. Using NMAP really got my juices going when I started my cybersecurity college degree. Great tool to get tangible information. Most definitely. Yeah, I've done a few Kali classes at Black Hat. So I'm familiar with NMAP and what it does, but it's kind of one of those things, since I don't use it in my daily life, it's not like I could, I don't remember all the switches and all that type of stuff. Except for the, I know that I want to see stuff in verbose mode, because who doesn't like more output whenever we're doing that type of stuff. So let's see. So moving on to task 3, like most pen testing tools, NMAP is run from the terminal. Versions available for Windows or Linux. For this room, we assume that you're using Linux. However, the switches are identical. NMAP is installed by default in both Kali and the TryHackMe box. Yep. So let's take a look here. We're going to go over into the browser. This is kind of like the default terminal that pops up. It's pretty much telling you not to be a punk and don't do anything bad. So, yeah. I'm going to open up another terminal just because I don't think I'm going to need any of these usage instructions, but that way, just in case I do, I'm not closing that out on myself. And we'll minimize that. Make that big so hopefully everybody can see that okay. Although maybe... zoom in a little bit. Get that a little bit bigger. There we go. So we're going to go NMAP. And I believe it was -H for help. Is going to kind of give us all of this different output for all of the different switches that we could use. Let's go back and take a look at what the question was. What is the first switch listed in the help menu for SYN scans? And I'm sure we're going to talk about what SYN scans are later. So I think scan techniques, TCP SYN, I think this is what that they're looking for, but see if there's any other things here that kind of pop out. Might make sense. Output, miscellaneous. No, I think that's going to be what it's going to be. So let's go hyphen lowercase s, uppercase s. And let's see. Bam. Okay, which switch would we use for a UDP scan? I bet you that's going to be a dash, lowercase s, and I think it's U, but let's see. Yep, so uppercase U. And got another comment coming in. I'm just finishing my college degree, moving to university, so still to use it in a real world situation. Cool. Let's see. If we wanted to detect which operating systems are running on the target, what would we use? So we're talking about fingerprinting stuff. Let's see. Service detection. We're to define what service version. So is that -SV, uppercase V? Let's see. Uh-oh, no. So we're not talking about specific service, we're talking about OS. My bad. IP protocol. Let's see. Script. OS detection. There we go. Dash capital O. And I think that O can get you in trouble because I think the lowercase o goes with output, if I remember correctly. So if you want to have the output of your scan put to different types of files. And I'm sure that we'll get to that eventually too. NMAP provides a switch to detect the version of services running on a target. Well, isn't that what I just said? I think that was capital S, lowercase v. Yep. The default output provided by NMAP does not provide enough information for a pen tester. How would you increase the verbosity? Well, I believe that is -V. And I think if you want to go even more verbose, I think it's a double V. Let's see. OS detection, output. Increase verbosity. Yep, there we go. And use double V if you want even more info. Cool. Verbosity level 1 is good, but verbosity, well, I mean, that's just what I said. We are in agreement. Let's go double V. All right, we should always save the output of our scans. This means we need to run the scan once, reducing network traffic and this chance of detection, and give us a reference to use when writing reports for clients. What switch would we use to save the NMAP results in 3 major formats? So I think that was hyphen. So that's going to be capital N for normal. No, okay. What switch would you use to save the NMAP results in 3 major formats? Oh, at once. Yeah, my bad. Capital A. And normal is what I just mistyped before. Capital N. Very useful output format. How would you save? Let's see. You want to output to all of them. I mean, that makes sense that way, depending upon what you're going to be using with it to look at them. Gives you some options there for sure. Very useful output for. How would you save in a greppable format? Capital G. I mean, come on, that's simple. I like it when the switches actually line up as far as the letter of the word that we're using for whatever it is that we want to do. That makes it easier. That's not always the case, depending upon what tool set you're using. Sometimes the results we're getting just aren't enough. If we don't care about how loud we are, we can enable aggressive mode. This is a shorthand switch that activates service detection, operating system detection, a trace route, and common script scanning. What is that going to be? Okay, well, it's going to be... Let's see. Scanning, scan techniques. Let's see. Right in front of me. Capital A. So A for all. I like it. Okay, NMAP offers 5 levels of timing template. These are essentially used to increase the speed of your scans. Be careful though, higher speeds are noisier and can incur errors. How would you set the timing template to level 5? Let's see. Timing. And so the higher the number, the faster it is. Okay, so that would be capital T for time and 5. Cool. We can also choose which ports to scan. I believe that is going to be -P and then the port number that you want. Cool. How would you tell NMAP to scan ports 1000 through 1500? Going to be similar thing. Think like that. Cool. A very useful option that should not be ignored. How would you tell NMAP to scan all ports? Oh, let's see. Exclude ports, fast mode. I'm sure that there is. Host discovery. Maybe it's back down at the bottom. Let's see if there was. So it's three characters. Let's go -lowercase sv. No? I don't know about that. We'll see what happens. Nope. Might have to Google this one. I mean, it would seem that if you don't specify the ports, it would scan all ports, but maybe I'm wrong with that. Let's see. How to scan all ports NMAP. Let's see. I mean, I might take you up on that here in a second. There we go. -P-. -P-. Let's see. Bam. There we go. Almost needed it. How would you activate a script for the NMAP scripting library? So that's going to be -S capital C. No. Activate a script for the NMAP. Google for the win. How would you activate? See if I'm missing something else there. Activate a script from the NMAP Scripting library. Yeah, I'm not sure on 1, 2, 3, 4, 2, 3, 4, 5, 6, 7, 8. 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, I don't know about that. I don't think that's right, but definitely not that. Okay. How do you activate all of the scripts in the vulnerability category? Well, let's try script equals full. Oh, let's try that. Sweet. And let's see what the hint would have given us. There are 2 variants of the switch, one with a space, one with equal signs. Look at the asterisk in the answer field to see which one it is. Okay, I don't know, that would help me. All right, move on to scan types. So a few different types: TCPs, connected scans, half open scans, UDP scans. So the way that I would try to remember that is capital T for TCP, knowing that this is a SYN half open scan, capital S, UDP, capital U. And then there are some less common ones: Null scans, FIN scans, XMAS, Christmas scans. And I'm sure that we're going to hit on those. So we'll go on to the next. And they're kind of breaking down what you would expect to see from a TCP scan. So you're going to get the SYN, the SYNAC, and the ACK. So your normal 3-way handshake. So what is the... Well, what RFC defines the appropriate behavior of the TCP protocol? 793? Not ROC. It's not ROC Nation. It's RFC. There we go. If a port is closed, what flag should the server send back to indicate this? A reset? So that's saying this indicates that a port is being protected by a firewall and thus it's filtered. That says easy. Yeah, let's see if that's right. Nope. Oh, well, let's try that. And don't auto-correct it. There we go. Here we go. On to the next. SYN Scan. So these are the half-open or stealth scans. So instead of sending back that ACK, once it gets the SYN ACK back from the target, it sends a reset. Okay. And why would we want to use this? Bypasses older IDSs. Scans are not logged by the... SYN scans are often not logged by the application. Okay. Because what, the three-way handshake doesn't complete, so that's why it doesn't care without having to bother completing through SYN scans, and it's going to be significantly faster. Okay. Disadvantages: require sudo on Linux, and unstable services can sometimes be brought down. Fantastic. Cool. There are two other names for SYN scans. What are they? Well, one was stealth and half open. Half open stealth. Can NMAP use SYN scan without sudo permissions? No. Submit. Sweet. Task 7. UDP Scan, stateless. Yep. Spray and pray. This happens... means instead of back and forth handshake, UDP connections rely on sending packets to the target port and essentially hoping... what I said, spray and pray. This makes UDP superb for connections that rely on speed over quality. Also, fun fact, why when you use VPNs, you use IPsec, why does IPsec use UDP? Why is that not a concern for connections going using an IPsec or VPN connection like that? Reason is because the IPsec VPN is relying on the host-to-host communication, so the TCP traffic that's being tunneled through the VPN. So it doesn't really care about whether or not the VPN itself has any type of protection mechanisms for retransmissions, because it will rely on the end host to figure that out and retransmit when they need to. All right, this makes UDP superb for connections. Yep. Acknowledgement of UDP significantly more difficult and slower. Okay, when a packet is sent to a closed UDP port, the target should respond with an ICMP packet containing a message that the port is unreachable. This clearly identifies the closed ports. Due to the difficulty in identifying whether UDP ports are actually open, UDP scans tend to be incredibly slow compared to TCP. For that reason, it's usually good practice to run NMAP scans with top port numbers enabled. For example, scanning NMAP, that means scan UDP, top ports 20, and that's going to be the most common UDP ports for that target. Okay. When scanning UDP ports, NMAP usually sends completely empty requests, just raw packets. That said, for ports which are usually occupied by well-known services, it will instead send protocol-specific payloads, which is more likely to elicit a response. Okay. If UDP port doesn't respond to NMAP, what will it be marked as? It will be, when it's sent, there should be no response. So it will be marked as open pipe filtered. Cool. When a UDP port is closed, by convention, the target should send back a port unreachable message. Which protocol would you use to do that? ICMP. Yeah, come on. Helps when I put that in there. No? Man. How about we spell it correctly? There we go. Cool, we're getting there. Any other questions or comments at this point? I'm going to take a sip of water. We're doing all right. I think we're almost halfway through. Yep. I think it's a few more of like these type of questions, and then there's a few like practical things where we're actually going to do some live commands on a test box, I think is how this goes. So these are some of the less common scans, the Null, the FIN, and the Christmas. They're interlinked. They tend to be stealthier. More stealthier than a SYN stealth scan, or the half-open scan that we talked about above. Null scans, TCP request sent with no flags. And we expect to get a reset if the port is closed. FIN scan. Going to send a FIN flag. Once again, we're expecting a reset if the port is closed. And then a Christmas scan is going to send a malformed TCP packet and expects a reset response for a closed port. It's referred to as a Christmas scan, has a flags that it sets. Give the appearance of blinking Christmas tree lights when viewed in Wireshark. Cool. Expected response for open ports with these scans is also identical and is very similar to that of a UDP scan. If the port is open, then there will be no response. Okay. Unfortunately, this is also the expected behavior if the port is protected by a firewall. So we'll only ever identify ports as being open, filtered, closed, or filtered. If a port is identified as filtered with one of these scans, it is usually because the target has responded with a ICMP unreachable packet. So the goal here is firewall evasion. Many firewalls are configured to drop incoming TCP packets to block ports which have SYN flags set. So that would be any new connections coming in through the firewall. They would block that. By sending requests that do not contain SYN flags, we effectively bypass that type of firewall. I don't know if that's really the case with more updated firewalls, if that's still like that. While this is good in theory, most modern IDS solutions are... there we go. Okay, so which of the three shown scan types uses the URG flag? That was the Christmas. Okay. Why are null, FIN, and XMAS scans generally used? Wasn't that firewall evasion? Which OS may respond to null, FIN, or Christmas scans with a reset for every port? That sounds like a Windows thing to me. Let's see if I missed reading that. In particular, Microsoft Windows and a lot of Cisco networking devices are known to respond with a reset to any malformed TCP packet. Yep. Microsoft Windows. Okay. Task 9, ICMP network scanning. Let's see. First connection. So ICMP scanning, we're talking about really getting a map of the network, seeing what's there. One way to do this is by using a ping sweep. Again, unless the environment that you're in blocks ICMP, which depending upon at what point in the environment you're plugged into, that may or may not be something that's blocked. This is exactly as the name sounds. NMAP sends out ICMP packets to each possible IP address for the specified network. When it receives a response, it marks the IP as responding and alive. To perform ping sweep, we're using the hyphen lowercase s n and then hyphen for the IP address. Okay. And so what the N there is doing is saying not to scan any ports and just rely on ping. Okay. How do you perform a ping sweep on 172.16 XX, so it's a /16 using NMAP. So NMAP, and then it was -SN, N for no port scanning, 172.16, 0.0, 255, 255, 0.0. What's up, Ty? I see you there. You got some Macallan over there or what? With a port of... Oh, no, we weren't doing any ports with that. We're just doing that. Okay. No? What did I say? Oh, using CIDR notation. Should have read that. /16. Ty Wilson, everybody. What's good? All right, let's see. Jameson, okay. I was thinking of bringing something up here, but really, since I figured I was going to be talking for a while, all I got is some water. And then if I feel like I'm going to pass out, I got, let's get that in shot, some Fairlife protein, which they just started putting this in Costco, at least out by me, and it is fantastic. It's delicious. Really, really good. Okay. Let's see. Moving on to NMAP Scripting Engine. We kind of talked a little bit about that when we were looking at the stuff under the help. Scripts are written, and I have no idea how to pronounce that. Is that Lua? Or L-U-A? Lua? It could be used to do a variety of things, from scanning vulnerabilities, automating exploits. NSC is particularly useful for reconnaissance. However, it's worth bearing in mind how extensive the script library is. And so the scripts have a whole bunch of different categories depending upon what it is that you want to do. And now we're going to look and see how to interact and make use of scripts in these categories. What is the language written in? It's written in the thing that I don't know how to pronounce. Lua? We're going to call it Lua. Could be way off. Which category of scripts would be a very bad idea to run in a production environment? Intrusive, I would say. Cool. And then in task 3, we looked at the -- script command, which is what we were using to activate scripts in the vulnerability category. Right? To run a specific script, we would use -- script equals and then the name. Cool. Multiple scripts can be run simultaneously in this fashion by separating them with a comma. Okay. That's cool. Some scripts require arguments. Okay. These can be given scripts -args. Okay. And they're giving us an example here of what this looks like. So the script is HTTP-put. Script argument is this URL. This one's taking 2 arguments, so it's that URL and that URL. Okay. Note that the arguments are separated by commas and connected with the corresponding script with periods. Script name and then the argument. Right. So HTTP-put, HTTP-put, period, and then the argument. Okay. NMAP scripts come with built-in help menus, which can be accessed using the NMAP -script -help and then the script name. Okay. What optional argument can the FTP -anon.nse script take? All right, so let's go back over to this. So it's going to be NMAP. Script, what's that? Script help? -help. -help. And then that was script name, so that's FTP anon.nse. FTP anon.nse. Let's see. Default auth safe. And what are we asking? We're asking so let's see what that says if we click on that. Let's see if that was okay. Oh, my bad. See if we can copy this out of here and put it in the browser. I don't know that that actually, well, should be able to open in a web browser. Copy link address, open tab. Oh, I'll keep opening up my command prompt. Let's try this. Let's see how good the web browser is on here. I'm gonna copy. Amazon. I don't like playing around with that. Let's just go, what's that? FTP anon. FTP anon. There we go. Okay. Is that max list? So let's see. Max list. Cool. All right. NSE scripts, searching for scripts. We know how to use the scripts, but we don't know how to find the scripts. So NMAP has a website. You also have local storage. User share NMAP scripts. 2 ways to search for installed scripts. One is by using the script database file. This isn't actually a database so much as a formatted text file. Yeah. So NMAP uses a file to keep track of all the scripts there. So you could grep for different things within that. The second way is to search the scripts is simply to use the ls command within the directory for that. And then we could use a wildcard or asterisk with the FTP to look for anything that has FTP. Okay. Could also do the same thing for categories. Okay. So let's go user share NMAP scripts. rid of this. CD user share NMAP scripts. And we were going to look for, what was it? SMB. SMB. Too many arguments. Oh, because I was doing a CD, huh? Let's do that. Dun, 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 dun. And there's a lot there. And what was the using? What is a file name and script to determine the underlying OS? Let's see. User share NMAP scripts, and that was SMB. System info, maybe? Or OS discovery. SMB OS discovery? Yeah. Let's go that one. SMB-OS discovery.nsc. This one. SMB.OS discovery.nsc. Cool. Read through this script. What does it depend on? Let's see. OS discovery NSC. What does it depend on? I'm not sure what it means by what does it depend on. Requires all of those things. See what the hint says. Look for dependencies in those brackets. Did I? Maybe I didn't get the whole file. Let's see. There we go. Definitely did not get the whole file. All right, let's see. We were looking for those brackets. There's a good amount of information. Output, dependencies, SMB-brute. There we go. Cool. Let us make sure that, yep, those are good. Grep it. Grep it's the way to go, for sure. Cat, the name of the script, pipe, grep, and then depend, or yes, yep. All right, let's see. I do want to make sure that we are not running out of time on this lab. I want to make sure. Let's see, firewall evasion. Should have a way to I know that eventually you need to like re-up your hours. Like I think there's something you have to hit to yeah, okay, let's see. Machine info, extend timer. There we go. Cool. Let's get out of that. Exit split view. Sorry about that, but I knew that we were coming up almost on an hour and I didn't want the box to cut off. All right, firewall evasion, we kind of were talking about that before with the Null fin and XMAS scans. So I need to get around. NMAP provides. So the -PN is going to be to not bother pinging before doing a scan. Probably because that would take up a bit of time if you were pinging everything and your host-based firewalls are blocking that. All right. There are a variety of other switches NMAP uses to consider useful for firewall evasion. Following switches are of particular note. -F is to fragment packets. Which will make them less likely to be detected by the firewall. I would assume unless the firewall or IDS is looking for fragmented packets. An alternative to -F is controlling the MTU size. I could see that being very useful in certain situations. Scan delay. Okay, yep. Yep, especially if you know what the defaults are of the tools or the protections that the firewall is using, that could be useful too. And bad sim. Okay. Which simple and frequently relied upon protocols often blocked, requiring the -P, and yeah, we just said that was ICMP. Why did that not take that? It keeps trying to auto-correct that, and that is super annoying. Okay. Which NMAP switch allows you to append an arbitrary length of random data to the end of a packet? Let's go to Google. So that is --data-length. --data-length. Cool. Now we get to actually doing something on the box. Hey, I'm back. All right, so I figured out what the issue was. Needed to log back out. Needed to log back in. Reload everything. Yeah, if you just give me 1 second, I'm going to just send out a message that I'm back on. Just let everybody know, because there were a few people there on the stream. There we go. All right, let's do this. This is just the last bit here, so we're going to knock this out. Sorry about that before. Really strange. So the last practical bit, see, and now it actually has the IP address of what we needed to use. Okay, so now we can do that Christmas scan again. And we were talking about using 92.24. All right. 92.24. And then we're going to let it go through and do its thing here. And 999 are open filtered, right? And that is because we got no responses. So how many ports are open or filtered? 999. There's a reason for this. What is this? Well, I think I just said it. No responses. Cool. Perform a TCP scan of the first 5,000 ports of the target. Okay. How many ports are shown to be open? So let's do that again. NMAP H. And let's go get that. TCP scan is going to be the Oh, no worries, Kiki. I got all the way up until the final part here, and the lab wouldn't load the IP address properly. So I had to shut down the stream and log out and restart it. So we're just kind of finishing it up. But we were going to do a TCP SYN Scan. So it's going to be the hyphen lowercase s capital S. Yeah, we got an hour into it, all the way through all 14 lessons, and got up to the end here, and yeah, no bueno. All right, so that was NMAP. And that was lowercase s, SYN, the IP address, 10.10.92.24, 10.10.92, let's see, 10.10.92.24. And what was the ports that it wanted us to do? The first 5,000 ports of the target. 0 through 4999. Let's go VV. And we'll see how long. So far, 1, 2, 3, 4, 5. We'll see if that is the answer. Yeah, cool. Okay, open Wireshark and perform a TCP connect scan on port 80 to the target. Monitor the results. Okay, so let's get... We'll just say completed there. And then we're going to deploy the FTP anonymous script against a box. Can NMAP log in successfully to the FTP server on port 21? So if we remember what that was, we'll just run this for kicks and giggles. We'll get rid of that real quick. Oh, let's do that port 80. We'll just do this scan just so we can say that we did it, and we can kind of see the output. And we see that it is open, and the reason why is because we got a SYN back, right? Okay. Now let's go NMAP. Now, if you remember, it was script equals FTP anon and let's go 10.10.92.24. Yes. So it went through to discovery. Then it started the NMAP Scripting Engine. So it's going to do that script that we called there. And it was able to read files from there. Cool. Okay, so the question was, can it log in? I would say correct. Awesome. And the conclusion, we've completed the further NMAP room. Awesome. That was fun. Glad to get through it. Sorry about that issue with the the IP not working or bringing up the vulnerable machine or the scanning machine. So yeah, that kind of sucked. But appreciate everybody checking it out. Again, yeah, we're gonna keep going through these Pentest Plus rooms that they have here on TryHackMe. I put a link for this room in the description of the video, so I hope that is beneficial to everybody. All right, we will chat later. Bye.